Hi, hello my dear students, a very good evening to all of you. Warm welcome to Turito live classes. In the last class, we have completed the chapter coordinate geometry. In today's class, we are going to start a new chapter, that is linear equations in two variables. So, this chapter is very important chapter. Already in 8th standard, we have discussed linear equations in one variable. Linear equations in one variable. In today class in 9th standard, in this chapter we are going to discuss linear equations in two variables. So, linear equation in one variable, by using that concept we can discuss linear equations in two variables. So, these concepts are very important, because in 10th standard we have quadratic equations like that. So, we can use the concepts of linear equations in so many chapters. So, we are going to start that chapter. Okay. So, linear equations in two variables. So, we are discussing linear equations in one and two variables and their solutions. So, learning objectives means what we are going to discuss in today class. So, we will learn the following concepts in this topic. First one, linear equations in one variable. So, actually already we have discussed linear equations in one variable in 8th standard only. So, once we can recap them. Next, solution of a linear equation in one variable. So, solution of a linear equation in one variable. When one linear equation is given, how to find the solution of that equation. Next, linear equation in two variables. So, this is our chapter name. So, already we have discussed these 2 points in 8th standard only, just we can recap them. Next, linear equations in two variables. Next, solutions of linear equation. So, solution of linear equation means the values of variables which satisfies the given equation. So, we are going to discuss these concepts and we can discuss some problems related to these concepts. Now, linear equation in one variable. Can anyone say? Already in 8th standard we have discussed linear equation in one variable. So, very simple one. So, just we can recap the definition. If A comma B belongs to R, means real numbers, capital R means real numbers, and A not equal to 0 means in place of A you may take any non-zero number, other than 0 you may take any number, then an equation of the form Ax plus B equal to 0 is called a linear equation in the variable x. So, where A and B are the constants, means we cannot change them, but x is a variable. In place of x you can take any value, in place of x you can take any value. So, that is why here we can change the value of x. So, that is why we are calling x is a variable. So, already here we have A not equal to 0. Here you may have doubt, sir, you are saying A not equal to 0, what about B? So, you may take B as 0, but A must be a non-zero number. If A equal to 0, then you will not get a linear equation. If A comma B belongs to R and A not equal to 0. So, actually Ax plus B equal to 0 is the linear equation in one variable. If you suppose that A equal to 0, so 0x, again you will get 0 only. From this you will get B equal to 0. So, this is meaningless. So, this is possible, this is true only when the value of B is 0. For the remaining values of B, this is not 0. So, for example, if you take 2x plus 3 equal to 0, 2x plus 3 equal to 0, in place of 2 if you take 0, then what will you get? 3 equal to 0. So, this is meaningless. So, 3 never equal to 0, 3 is equal to 3 and 0 is equal to 0 only. So, that is why you must take A not equal to 0. So, if you take only 3x equal to 0, so we can say that is a linear equation. Actually, there is no constant. In place of B we do not have any value, still we can say this is a linear equation in one variable. If A comma B are real numbers and A not equal to 0, then an equation of the form Ax plus B equal to 0 is called a linear equation in the variable x. Example, 2x plus 3 equal to 0. So, just we have taken that example, and root 3 y minus 1 equal to 0. So, linear means the power of the x, the power of the variable, x means variable, the power of the variable must be 1. If you take here the power of x, that is 1. Here if we take y is a variable, the power of y is 1. So, this is the first degree equation, 2x plus 3 equal 0. Root 3 y minus 1 equal 0 is also a first degree equation. So, if the degree of the given equation is 1, then we can say that is a linear equation in one variable. If a comma b belongs to R and a not equal to 0, then any equation of the form ax plus b equal 0 is called a linear equation in the variable x. So, these are the examples of linear equations. So, already we have discussed linear equation in one variable in previous class, means in 8th class only. Next, solution of a linear equation in one variable. Solution means the value of the variable, which satisfies the given linear equation is known as the value of the given linear equation. The value of the variable, if you suppose that the variable is x, so it is not necessary to take x only, you may take y, k, t, whatever it may be, whatever the variable may be. The value of the variable, say x, which satisfies the given linear equation is called the solution of the linear equation. So, satisfies the given equation means in place of the variable by substituting some value, after simplification you must get 0. Then that value is known as solution, that is also known as root of the given linear equation. The value of the variable, say x, which satisfies the given linear equation is called the solution of a linear equation. So, example, x equal to 2 is the solution of x minus 2 equal to 0. Here we have x minus 2 equal to 0. Here I am saying x equal to 2 is the solution for this linear equation. Why? In place of x, if we take 2, then what will you get? 2 minus 2, we are getting 0. So, that is why this x equal to is known as root or solution of the linear equation x minus 2 equal to 0. So, x equal to is the solution of x minus 2 equal to 0. Second one, z equal to minus 1 by 3 is the solution of the linear equation 3z plus 1 equal to 0, where the variable is z. In place of z, here we have the equation 3z plus 1 equal to 0. In place of z, if we write minus 1 by 3, in place of z by writing minus 1 by 3, 3z, 3 into minus 1 by 3 plus 1, where plus 3, so 3 get cancelled. In numerator and denominator we can cancel 3. Here minus 1 plus 1 is there, minus 1 plus 1 cancel 0. In place of z by substituting minus 1 by 3, we are getting 0, means this equation is satisfying. That is why we can say z equal to minus 1 by 3 is the solution of 3z plus 1 equal to 0. X equal to 2 is the solution of x minus 2 equal to 0. Okay. So, the value of the variable which satisfies the given linear equation is known as solution of the given linear equation. Solution can be also treated as root. Solution or root, both are same. Okay. So, hope you understood more. Now, let us do some problems related to linear equations in one variable. Okay. So, linear equations in one variable. So, just we have discussed what is the linear equation in one variable and what is the solution of the linear equation in one variable. Now, look at this. Solve 3x plus 11 equal to 6x minus 13. Solve 3x plus 11 equal to 6x minus 13 by observing this equation. So, if you remember in 8th standard we have discussed the linear equations having the variables on both sides, having the variables and constants on both sides. By observing LHS part, 3x plus 11, x 3 11 are constants. By observing RHS, 6x minus 13, where 6 minus 13 are the constants and x is a variable. So, when we have the variable and constants on both sides, we have to write the variables on LHS and we have to write the constants on RHS and we can simplify. So, after simplifying that, you will get the value of x, that is the solution of the given linear equation. So, 3x plus 11 equal to 6x minus 13. So, in RHS we have 6x. By writing x terms in LHS and by writing constant terms in RHS. So, if you take 6x to this side, so 3x minus 6x equal to. So, in 8th class we have transposition method for solving the given linear equations in one variable. Transposition method means we have to transpose the terms from one side to another side. One side to another side means from LHS to RHS, from RHS to LHS. When we transpose the terms from one side to another side, means from LHS to RHS or from RHS to LHS, we have to change the sign. We have to change the sign. If plus is there, write minus. If minus is there, take plus. Here plus 6x is there. By writing that 6x in LHS, we can write minus 6x. Similarly, here we have 11. By writing 11 in RHS, we can write minus 11. By taking 11 to that side, minus 13 minus 11, where 3x minus 6x is minus 3x. 3x is positive, 6x is negative. By subtracting 3x from 6x, we got 3x. So, since x is greatest value and that contains negative sign, we have minus 3x equal to minus 13 minus 11 minus 24. To get the value of x by dividing on both sides by minus 3, minus 24 by minus 3, minus minus get cancelled, 3 8 times cancel. So, you will get x equal to 8. So, this is the solution of the given linear equation in one variable. Here in the given equation we have only one variable, that is x. We have only one variable, that is x. By solving this equation we got x equal to 8. If we substitute x equal to 8 in LHS and RHS, those two must be equal. So, from that we can say our answer is correct. So, hope you understood, ma'am. Next one. So, here we have one written problem. So, sometimes we may not have the given linear equations in the standard form. So, standard form means Ax plus b equal to 0. Sometimes they may give in the standard form, sometimes they may not give, mean they can give the problems in descriptive manner like this. According to the given problem, we have to express the linear equation in the standard form Ax plus b equal to 0. From that we can solve the equation. Now, look at this one. A swarm of 62 bees flies in a garden. If 3 bees land on each flower, 8 bees are left with no flowers. Find the number of flowers in the garden. One garden is there. In that garden, we have some flowers. We have some flowers. On flowers, some bees are there. A swarm of 62 bees. Total 62 bees are there. They flies in a garden. If 3 bees land on each flower, so first flower 3 bees, second flower 3 bees, 10th flower 3 bees. On each flower there are 3 bees and 8 bees are left with no flower. 8 bees are there. So, just they are flying in the air only. So, they do not land on any flower, are left with no flowers. Find the number of flowers in the garden. So, this is the problem. So, according to this problem, we have to form a linear equation in one variable. So, since we have to find the number of flowers, let us suppose that that is some x. Let x be the number of flowers in the garden. Let x be the number of flowers in the garden. According to the given problem, total number of bees is 62. Total number of bees is 62. So, since we are taking exceed the number of flowers, if 3 bees land on each flower, so number of flowers on the flowers equal to 3 times of x. So, for example, 2 flowers are there, 2 into 3 6 bees. If 10 flowers are there, 10 into 3 30 bees. So, since we are taking the number of flowers is x, then number of bees on flowers equal to 3x. 8 bees are left with no flower. The number of bees with no flower, the number of bees with no flower equal to 8. by adding 3x and 8, you will get the total number of bees, that is 62. So, you will get 3x plus 8 equal to 62. Simplify that, you will get the value of x, that is nothing but the number of flowers in the garden. Here I am supposing x is the, let x be the number of flowers in the garden. Let x be the number of flowers. Let x be the number of flowers in the garden. So, according to the problem, a swarm of 62 bees fly in a garden. If 3 bees land on each flower, so number of bees on flowers equal to number of bees on flowers. So, since we are taking the total number of flowers is x, number of bees on flowers equal to number of bees on flowers equal to, so 3 bees and number of flowers is x. So, total number of bees can be taken as 3x, that is given. Next, 8 bees are left with no flower. Number of bees with no flower. Number of bees with no flower equal to number of bees with no flower equal to 8. So, 3x is the number of bees on the flowers, 8 is the number of bees having no flower. By adding these two, you will get the total number of bees. So, given that the total number of bees equal to 62. Total number of bees means number of bees on the flowers and number of bees having no flower. So, that is number of bees on the flowers is 3x. Number of bees having no flower is 8. So, 3x plus 8 equal to, here we have 62. 3x plus 8 equal to 62. If we take 8 to that side, so 3x equal to 62 minus 8. So, 3x equal to 62 minus 8, 12 minus 8, 4, 54. To get the value of x by dividing on both sides by 3, you will get x equal to 54 by 3. 3 1 ja 3, 3 8 ja 24. X equal to 18, but we have taken x is the number of flowers. So, number of flowers in the garden equal to 18. Therefore, number of flowers in the garden equal to 18. Simple. So, since we do not know the number of flowers, you can take that is x. Next, the number of bees on each flower is 3. So, the total number of bees on the flowers is 3x. Number of bees in the air means having no flower is 8. By adding these two, you will get the total number of bees, that is 62. After simplifying, we got x equal to 18. So, the total number of flowers in the garden equal to 18. Hope you understood, ma'am. So, in the above problem, they have given the linear equation by having variable and constant. Here they have not given any linear equation, just they have given the problem in descriptive manner. According to that problem, we have formed a linear equation. Next one. Solve 5x by 3 plus 2 by 5 equal to 1. So, this is also a linear equation in one variable, because here we have one and only one variable, that is x. Here we have one and only one variable, that is x. So, here 5 by 3 and 2 by 5 both are rational numbers. Okay. So, to solve this equation, so first of all we have to simplify the LHS part, where the denominators are 3 and 5. So, since they are different, you can take the LCM of 3 and 5 and you can cross multiply. From that, you will get the value of x, that is the solution of the given linear equation. So, 5x by 3 plus 2 by 5 equal to 1, where the denominators are 3 and 5. For 3 and 5, the LCM is 15. If we divide 15 by 3, you will get 5, 3 5s are, where numerator is 5x, 5 into 5x, 25x. By dividing 15 by 5, 3, where the numerator is 2, 3 into 2, 6, equal to 1. By cross multiplying, you will get 25x plus 6 equal to 15 into 1 is 15. So, 2x plus 25x plus 6 equal to 15, clearly this is a linear equation. If you take 6 to that side, so here plus 6 is there, by transposing this 6 to RHS, you will get minus 6, 25x equal to 15 minus 6. So, from this you will get 25x equal to 15 minus 6 is 9, 15 minus 6 is 9. So, by dividing on both sides by 25, we got x equal to 9 by 25. To get the value of x by dividing on both sides by 25, we got 9 by 25. That is the solution or root of the linear equation 5x by 3 plus 2 by 5 equal to 1. So, when we have the rational numbers, first we have to check whether the denominators are same or different. If the denominators are same, directly we can add the numerators. So, in 8th standard we have discussed linear equation rational numbers. According to that, if the denominators are different, then you can take the LCM of the denominators and simplify them. Okay. Next problem. Solve 2 by 3x minus 3 by 2x equal to 1 by 12. So, just like the previous problem, here the denominators are 3x and 2x, only x is common, 3 and 2 are different. Again, by taking the LCM, 2 by 3x minus 3 by 2x equal to 1 by 12. 2 by 3x minus 3 by 2x equal to 1 by 12. By taking the LCM of 3x and 2x, so x is common. For 3 comma 2, the LCM is 6. So, we can take 6x as LCM. By dividing 6x by 3x, xx get cancelled, we can cancel 6 by 3 2 times, where the numerator is 2, 2 2 ja 4, minus by dividing 6x by 2x, xx get cancelled 2 3 times, 3 3 ja 9 equal to 1 by 12, equal 1 by 12. So, from this we can write 4 minus 9 minus 5 equal to, by cross multiplying you will get 6x by 12, 6x by 12. So, we can cancel 12 by 6 2 times. So, by cross multiplying, here we have RHS is x by 2, LHS is minus 5. By cross multiplying you will get x equal to 2 into minus 5. So, 2 5 are 10, but minus is there. So, the value of x is minus 10. So, solve 2 by 3x minus 3 by 2x equal 1 by 12. Take 6x as LCM in LHS and simplify. Finally, we got x equal to minus 10. Next, if a minus 8 by 3 equal to a minus 3 by 2, then find a. So, in 8th standard we have cross multiplication method. To solve the linear equations in one variable, we have cross multiplication method. According to that method, we can solve this. Here the variable is given as a. Whatever the variable, sometimes we may have x, sometimes we may have y, sometimes we may have a. Whatever the variable may be, the procedure is same. Here we have a minus 8 by 3 equal to a minus 3 by 2. By cross multiplying, a minus 8 into 2. So, 2 into a minus 8 equal to 3 into a minus 3. So, from this 2 into a, 2a minus 2 8 ja 16 equal to 3 into a, 3a minus 9. If you take 3a to this side, 2a minus 3a. If you take minus 16 to that side, that should be plus 16, minus 9 plus 16. 2a minus 3a is minus a. 16 minus 9 is 7. By multiplying on both sides by minus 1, you will get a equal to minus 7. So, that is the solution for the given linear equation a minus 8 by 3 equal to a minus 3 by 2. Simple problem. Just we can cross multiply and simplify. Next, linear equations in two variables. So far we have discussed linear equation in one variable. So, just we have reviewed the concepts which we have discussed in the 8th standard. Now, linear equations in two variables. So, linear equation in one variable means Ax plus b equal to 0. Just like that, we can define linear equation in two variables. If a, b, c are real numbers and a not equal to 0, b not equal to 0, a and b are non-zero real numbers, then an equation of the form ax plus by plus c equal to 0 by observing where two variables are there x and y. Two variables are there x and y, a, b, c are the constant. So, when we are taking linear equations in one variable, just you can take a not equal to 0, means you may take b equal to 0. If you take linear equation in two variables ax plus by plus c equal to 0, where you can take a and b not equal to 0, if you want you can take c equal to 0, 2x plus 3y equal to 0, that is also linear equation in two variables. So, is called a linear equation in two variables x and y. Example, 3x minus 4y plus 2 equal to 0, this is exactly in the form of ax plus by plus c equal to 0, where a equal to 3, b equal to minus 4, c equal to 2. Next, 0.4x plus 0.3y equal to 2.7. You can take the numbers as your wish. It is not necessary to take the integers. So, if you want, you can take positive integers, negative integers, rational numbers, irrational numbers, whatever the numbers may be, but that equation must be in the form of ax plus by plus c equal to 0. Here we have doubt. So, in the second example, we have the equation 0.4x plus 0.3y equal to 2.7, but that is not in the form of ax plus by plus c equal to 0. Very simple. Just you can take 2.7 to this side, 0.4x plus 0.3y. If you take 2.7 to this side, minus 2.7 equal to 0. Now, this equation is exactly in the form of ax plus by plus c equal to 0, a equal to 0.4, b equal to 0.3 and c equal to minus 2.7. So, any equation of the form ax plus by plus c equal to 0. So, how can we take the difference between linear equation in one variable and linear equation in two variables? Very simple. Linear equation in one variable means there exists one and only one variable and the equation should be in the form of ax plus b equal to 0. Linear equation in two variables means there exist two variables x and y and the standard form of the equation is ax plus by plus c equal to 0. Okay. So, if a, b, c are real numbers and a not equal to 0, b not equal to 0. So, for example, if you take a equal to 0, then what we get? by plus c equal to 0. Here we have only one variable. So, that is why we can say this is the linear equation in one variable. If you want, you can take c equal to 0. So, for example, if we have 5x plus 7y equal to 0. So, this can be taken as linear equation in two variables. Actually, constant c is not there. Still, we can say this is the linear equation in two variables. So, these are the examples of linear equations in two variables. Now, let us do some problems related to linear equations in two variables. Look at this. Write the equation 3x minus 8 equal to 5y in the form of ax plus by plus c equal to 0 and write the values of a, b, c. Actually, the given equation E contains two variables x and y, but that is not in the standard form. Standard form means ax plus by plus c equal to 0. We have to express the given linear equation in the standard form ax plus by plus c equal to 0. Then we have to find the values of a, b, c. The given equation is 3x minus 8 equal to 5y. So, if you take 5y to this side, 3x minus 5y minus 8 equal to 0. If you take 5y to this side, 3x minus 5y minus 8 equal to 0. Now, this equation exactly in the form of ax plus by plus c equal to 0. So, if you want, you can write 3x plus minus 5 into y plus minus 8 equal to 0. 3x plus minus 5 into y plus minus 8 equal to 0. Now, this equation is exactly in the form of ax plus by plus c equal to 0, where a equal to 3, b equal to minus 5 and c equal to minus 8. So, write the values of A, B, C, where A equal to 3, B equal to minus 5 and constant C is minus 8. Very simple problem. So, the given equation is not in the standard form. By transposing 5y which we have in RHS to LHS, now the equation is converted into Ax plus By plus C equal 0 form, where A equal to 3, B equal to minus 5 and C equal to minus 8. Next, write the equation x by 3 minus y by 2 equal to 5 in the form of Ax plus By plus C equal 0 and write the values of A, B, C. Here we have x by 3 minus y by 2 equal to 5. Okay. So, in LHS we have denominators 3 and 2. So, for 3 and 2 by taking 6 as LCM, or if you take 5 to this side. So, if you take 5 to this side, x by 3 minus y by 2 minus 5 equal to 0. X by 3 minus y by 2 minus 5 equal to 0. By taking 6 as LCM, if you divide 6 by 3, you will get to where the numerator is x 2x minus, by dividing 6 by 2, you will get 3y minus 5 means 5 by 1. If you divide 6 by 1, you will get 6 5s are 30 equal 0 by cross multiplying. By cross multiplying 0 into 6 equal 0. If you multiply any number by 0, again you will get 0 only. So, from this you will get 2x minus 3y minus 30 equal to 0. So, where this is exactly in the form of Ax plus By plus C equal 0. If you want, you can write like this: 2x plus minus 3 into y plus minus 30 equal to 0. So, where A equal to 2, B equal to minus 3, C equal to minus 30. So, if you take 6 as LCM in LHS, you will get the values of A, B, C like this. If you do not take LCM, so if you take x by 3 minus y by 2 equal to 5, x by 3 minus y by 2 minus 5 equal 0, where x by 3 can be written as 1 by 3 x minus 1 by 2 can be written as plus minus 1 by 2 y minus 5 equal to 0. Now, this is also in the form of Ax plus By plus C equal 0. So, that is why you can write A equal to 1 by 3, B equal to minus 1 by 2, C equal to minus 5. This is also correct. If you take 6 as LCM, then you will get the values of A, B, C as A equal to 2, B equal to minus 3, C equal to minus 30. If you compare the given equation directly with Ax plus By plus C equal to 0, then you will get A equal to 1 by 3, B equal to minus 1 by 2 and C equal to minus 5. So, both are correct. Next, if A equal to root 2, B equal to 4 and C equal to minus 3, then write the linear equation in the variable x and y. So, we know the linear equation in two variables in the standard form is Ax plus By plus C equal to 0. So, let the linear equation be, let the linear equation be Ax plus By plus C equal to 0. Let the linear equation in the variables x and y be Ax plus By plus C equal to 0. According to the problem, we have A equal to root 2, B equal to 4, C equal to minus 3. In place of A, B, C, by substituting the given values Ax root 2x plus By plus 4y plus C minus 3 equal to 0. In the above problem, they have given the equation. From that equation, we have found the values of A, B, C. Here they have given the values of A, B, C. According to those values of A, B, C, we have formed the linear equation in the standard form, that is root 2x plus 4y minus 3 equal to 0. Next, x plus 5y equal to 4 in the form of Ax plus By plus C equal to 0 and determine the values of A, B, C. So, we have 5y equal to 4. Actual x term is not there. So, actually this is the linear equation in one variable only, but we have to express that in the form of Ax plus By plus C equal to 0. So, since x term is not there, we can write that is 0x. Since x term is not there, we can take that is 0x plus 5y. If you take 4 to this side, minus 4 equal to 0. Now, this equation is in the form of ax plus by plus c equal to 0, where a equal to 0, b equal to 5 and c equal to minus 4. By comparing with ax plus by plus c equal to 0, a equal to 0, b equal to 5 and c equal to minus 4. So, 5y equal to 4, actually that is the linear equation in one variable only. So, since x term is not there, I have taken that as 0x plus 5y minus 4 equal to 0. By comparing with ax plus by plus c equal to 0, we have a equal to 0, b equal to 5 and c equal to minus 4. Next, solutions of linear equation. So, already we have discussed solution of a linear equation in one variable. Just like that, solution of linear equation in two variables. The values of x and y which satisfy the linear equation ax plus by plus c equal to 0 are called the solutions of the linear equation. If you take a linear equation in one variable, there exists one and only one solution. So, because there exists only one value of the variable satisfy the given equation, but here there exist two values because two variables are there. The values of x and y which satisfy the linear equation ax plus by plus c equal to 0 are called the solutions of a linear equation. If x equal to alpha and y equal to beta are the solutions of ax plus by plus c equal to 0, then in place of x by writing alpha, in place of y by writing beta, you will get a alpha plus b beta plus c equal to 0. Okay. If we suppose that x equal to alpha and y equal to beta are the solutions of ax plus by plus c equal to 0, you will get a alpha plus b beta plus c equal to 0, where alpha beta are some constants. Example, x equal to 3 and y equal to 2 are the solutions of 5x minus 3y equal to 9 or 5x minus 3y minus 9 equal to 0. In place of x, if we take 3, 5 3 is 15. In place of y by writing 2, 3 2 is 6 minus 9. 15 minus 6, 9 minus 9, we are getting 0. So, that is why we can say x equal to 3 and y equal to 2 are the solutions of the linear equation 5x minus 3y equal to 9. So, the values of x and y satisfying the linear equation ax plus by plus c equal to 0 are called the solutions or roots of the linear equation ax plus by plus c equal to 0. If we suppose that x equal to alpha, y equal to beta are the solutions of ax plus by plus c equal to 0, then we can write a alpha plus b beta plus c equal to 0. So, this is the example. Come on, next. Note, a linear equation in two variables may have infinite solutions. So, may have infinite solutions. So, it is not necessary one and only one solution satisfies the given linear equation. So, for example, if we take for the linear equation x minus y equal to 0, the solutions are minus 1 comma minus 1, 0 comma 0, 1 comma 1, 2 comma 2, 3 comma 3, so on. So, if you take x minus y equal to 0, where we have minus 1 comma minus 1, in place of x write minus 1, in place of y by writing minus 1, minus of minus plus 1, both are cancelled, we will get 0. Similarly, by taking 0 comma 0, 0 minus 0 equal 0, 1 comma 1, 1 minus 1 equal 0, 10 comma 10, 10 minus 10 equal 0, 1 by 2 comma 1 by 2, 1 by 2 minus 1 by 2 equal 0. So many values are there for x and y satisfying the equation x minus y equal to 0. So, that is why it is not necessary that the linear equation in two variables may have one and only one solution. That equation may have infinite number of solutions. We can conclude that by taking this example. Okay. Now, let us take some problems related to linear equations in two variables. Yeah. If x equal to 2, y equal to 1 is a solution of 2x plus 3y equal to k, then find the value of k. So, just we have discussed, if x equal to alpha and y equal to beta are the solutions of ax plus by plus c equal to 0, then a alpha plus b beta plus k equal to 0. Here the given equation is 2x plus 3y equal to k. According to the problem, we have x equal to 2 and y equal to 1. So, in this equation, in place of x by writing 2, in place of y by writing 1. So, put x equal to 2 and y equal to 1. According to the problem, we have x equal to 2 and y equal to 1. In place of x by writing 2, 2 into 2. In place of y by writing 1, 3 into 1 equal to k. So, 2 into 2, 4, 3 into 1, 3 equal to k. 4 plus 3 equal to 7. So, you will get k equal to 7. So, 2x plus 3y equal to 7 or 2x plus 3y minus 7 equal to 0 is the linear equation in two variables x and y. So, substitute x equal to 2 and y equal to 1 in the given equation. After simplification, we got k equal to 7. Next, if x equal to 2k minus 1 comma y equal to k is a solution of 3x minus 5y minus 7 equal to 0, then find the value of k. Here we have the equation 3x minus 5y minus 7 equal to 0. For this linear equation 3x minus 5y minus 7 equal to 0, we have the variables x equal to 2k minus 1 and y equal to k. X equal to 2k minus 1 and y equal to k. So, in place of x by writing 2k minus 1 and in place of y by writing k. So, 3x 3 into 2k minus 1 minus 5y in place of y by writing k minus 5k minus 7 equal to 0. By multiplying 2k minus 1 by 3, 3 2 ja 6k, 3 into minus 1 minus 3 minus 5k minus 7 equal to 0, where 6k minus 5k. So, k by writing k terms at one place and by writing constant terms at one place. Here we have 6k minus 5k is k minus 3 minus 7 minus 10 equal to 0, where 3 is negative, 7 is also negative. So, since these two numbers are negative numbers, by adding them we got minus 3 minus 7 minus 10 equal to 0, k minus 10 equal to 0. By taking 10 to that side, you will get k equal to 10. So, this is the solution of the linear equation 3x minus 5y minus 7 equal to 0 when x equal to 2k minus 1 and y equal to k. So, just substitute x equal to 2k minus 1 and y equal to k in the given equation and solve. After simplification, we got k equal to 10. So, just like this you can solve this problem. If x equal to 3k plus 2, y equal to 2k minus 1 is a solution of 5x minus 3y equal to k, then find the value of k. So, in place of x you can write 3k plus 2 minus 3y, in place of y we can write 2k minus 1 equal to k. So, 5 into 3 15k plus 5 2 ja 10 minus 3 2 ja 6k minus 3 into minus 1 plus 3 equal to k, where 15k minus 6k 9k 10 plus 3 13 equal to k. If you take k to this side and 13 to that side, you will get 9k minus k equal to minus 13. 9k minus k is 8k equal to minus 13 by dividing on both sides by 8. So, we got k equal to minus 13 by 8. Okay. So, we have discussed these concepts in today's class in the chapter linear equations in two variables. So, linear equation in one variable, solution of a linear equation in one variable, linear equations in two variables and solutions of linear equation. In the next class, we can take another concept in the same chapter linear equations in two variables and we can discuss some problems related to that concept. So, thank you all my dear students for subscribing to Turito. Have a nice day.